Who was that?
Yeah, I was talking about it. Yeah.
Yeah, do you know anything about like do you work at Microsoft?
Yeah. Yeah. I do.
You work with Substrate?
Yes,
You
I
work
do.
on the Substrate team. Okay.
Yeah. Yeah.
Can I ask you a few questions afterwards, if you don't
Yeah.
mind?
Sure. Definitely. Yeah.
Okay.
Okay, so let's start today's session. So today, just like last time, we are going to discuss the design of the object storage. So you can see I'm recording now, and last time we were discussing how to design the backend of the object storage. We are talking about using several. You can see that from our whiteboard. We are going using it's kind of messy. Some AIs, I can remember, maybe that's the front end server, and they have some backend server that doing a bunch of things. Okay, so around this time, is there anybody interested in trying to start this design? I'm calling for volunteer for this time. Continue design the backend. Anyone? Here is what we left from the last time.
So yeah, do we want? So what's the plan? Are we going to start from the beginning, or are we going to start?
Yeah, we can focus mainly on the backend to see how we want to continue design this system. Because last time I think I remember that at least I have some question that like in this system, because we like the replication to be only 3, so each time we would store one block, one chunk, we put into one group of the group of replications here. So I wonder that if we have some dynamic replication, like some data is important, some data not, and how we are going to handle this, and also how we handle the case when we replace the backend disk. So this is a question I want to ask in this session.
So what was the second part? One is how do we make replication dynamic? And
yeah.
what?
Another one is that, so let's say that we have multiple machines and each machine will have a lot of hard drives because hard drive is pretty cheap. But if we want to swap up the hard drive because they fail, how we are going to recover from this?
So if the hard disk fails, if the machines fail, how do we recover from that, right?
Yeah.
Okay.
And if there could be other questions I can't remember. I didn't write it down anywhere.
Okay. Yeah.
Do you want to try?
Sure. Yeah. So
okay. Let me stop sharing so you can share that. Can everybody have access to the whiteboard and the coder pad? Maybe I can put them in the Zoom chat just in case.
Okay. Just to quickly go over the high-level overview, like 5 minutes, what we discussed last time. So when a request comes, first let's see when a write request comes, when I want to store some data in blob storage, right? So load balancer will send that request to one of the application servers. The application servers will make a call to a service. So basically a monitor. So let's say we have these set of nodes which are running, which can store the data. So a monitoring service will be looking at them and telling me that on this particular node, how much free space I have, right? Now, when a request comes to store some data, and we would know how many bytes we are going to store. So it is going to look up in this metadata storage table that what machine I can store that data in based on the available space. Once it decides that, it will then store that information, that this ID data, so each data will have some ID. So this ID data is stored in uh, these nodes. So each set of node will be represented by ID. So that data is stored in that ID, and then it will start writing that data to those IDs, right? So this is a write request. For the read request, so for that data ID, I will have in that table that at what nodes I stored the data, so I will retrieve the data, right? Similarly, if I want to delete the data, I will just delete the data looking at the ID and machine. I will mark it as deleted. This monitoring service will be keep on running on those machines. So it will update that what is the free space I have accumulated on those nodes. And then whenever a new request comes, that can claim that space, and basically that space would be then reused, right? So this was overall kind of like a happy path. Everything is working and those kind of situations. Now going to the first question here, that uh, so how do we replicate differently for different size, right? So basically what we can do is we can abstract this portion to the replication service. So to the replication service, we are, whenever we are making a write request, we are saying this, that these are the bytes, and I want to replicate these bytes in these many nodes. So the replication service will take that request, and now it's the responsibility of replication service to replicate that data in those many nodes, right? So now it could be dynamic or whatever your application service can handle that logic, that it has to pass how many nodes it wants to replicate, and the replication service will take care of it. So uh, yeah, but and this is if we are, so are we saying that the number of replication will be different for each file, or like for each subscription or a user account? Once you have set that replication number, it will be same across all the files he's storing?
I would say that maybe depend on the user. So there are some, maybe there are some metadata saying that those objects are important. They should be distributed into more than 3 nodes or maybe 5 nodes. That's my thinking.
So yeah, so then yeah, so then what I said initially, that this application service will parse that request, and as you have mentioned in that request, the user will specify the importance and the replication factor, so that it will parse and send this value to the replication service, and then replication service will then include it.
Oh, I don't follow that.
Uh, okay, let's go down. Probably we can draw or write something. So basically my replication service, right? Uh, so you will send me bytes data, and then
if you have a lot of text, you can try to use coder pad.
yeah, okay, for this I'm done right now, but probably yeah. So this so basically for replication service we will be so replication services storing my data, right? So I will be sending it two kind of request. That one request is write the data, and one thing is get data. So when I am sending it request to write data, which is bytes, I will be also sending replication factor, right? And when I want to get the data, I will be just.
You have the right data, have the replication factor. I think that it would be better that replication factor is part of the object's metadata. So when you create,
Okay, so
I think that's fine because if you write the data, that actually create a new object. So then we can put the rep factor there. Is what you're trying to do?
so you're saying first time when we create the object, there we are storing this information, and then
Because the object is immutable, so you can only write once, and then that's it. Unless you have the upload object, like if the object is super big, you have to initialize and update and update different part, and then finish the request.
okay. So yeah. So what are you suggesting? What is the alternate approach?
That's it. Usually the API for the object storage.
What's the API?
Usually,
we wrote all that last time, and that got erased, right? I forgot.
Let me find something.
Okay, so somewhere we should also store this replication factor so that it's not get lost. So this replication service will have its own data storage, which will be file ID, replication factor, and file.
Hey guys, sorry I just joined now. Can you give me just brief summary what we discussed till now?
Oh, we are trying to continue to design the object storage, and we are currently designing the backend, focusing on the backend.
Okay, the same problem which we were doing last week.
Yeah.
In that problem, Asim, there are two things that we are discussing. One is that how can we make dynamic replication factor?
Mm-hmm.
It was fixed, right? So if a user says for this file I need these many replication, that should be dynamic.
Okay.
So I was suggesting that part we can abstract out to the replication service. So to the replication service, when we are sending the write request, we are telling it how many nodes it needs to replicate to, and then this
So Abhishek, is it something user will tell I want these many replication?
Yeah, this is what Heran has suggested as a design that.
Yeah, I was suggesting that either the user say that this bucket need a higher replication factor or not.
I thought it was based on subscription, that once you are like taking a subscription for that, you will define the replication factor. But
Yeah,
I
So,
don't
maybe
know.
but what is advantage to user for defining? I can define 100 replication, but what it is giving advantage to the end customer or end user?
because the data is easier, not is safe, and the data may be lost, and we have the higher replication to guarantee that data is won't lost and will be available, and also and if you have higher replications, if 100 replications, customer need to pay a lot.
I think that is
So
what
that is something our service should guarantee. Like once you give the data, we will keep it for you. You don't worry about that. That how many times we replicate. That is my worry about how I will replicate. Now I'm telling user, okay, I will replicate your data this much. Would not, I don't know, even I have not seen with the current S3 where I tell like, okay, I need this much replication. I only tell, okay, just upload data and now I have a guarantee that I'll get that data back. And then again, it could be like multi-region if I want to support different regions, availability zones.
Yeah.
That's it.
Okay, I see. I think makes sense.
I would say like that replication factor is our choice, how much we want as a developer to make sure that we'll not lose the data. But giving flexibility to user, I don't see any advantage.
So yeah, one advantage I that would be, so replication also helps in read scalability, right? So that means that if my some file, I think it is very frequently used by a lot of users simultaneously, then I would want to replicate it so that I can divide the load, right? And so like that's one use case where I think that you would want a higher replication factor.
But is it like user will do the calculation for me? User will say like I have 100 users, replicate 100 times.
And user, yeah, I mean, for me, for user, I am just a service, right? And I will say that as a service for a particular file, I can give you a maximum maximum reads of, let's say, 5 requests per second. But now I say that my request is not 5 requests per second, it is more. So then I will do a calculation that I will see in my data that I'm getting generally 50 requests per second. So I will ask this service that replicate my data this many times so that I can serve 50 requests per second.
So is it something like, okay, is it something we will tell user upfront, like if you make replication 5 times, I can support 10 reads per second?
So replication is used for multiple things. So one part of replication is we want to replicate data so our data is durable. That we will anyways do.
So data loss, yeah.
Data loss. But other thing I'm saying is that so that we will not count in like read scalability and also
Yeah, correct.
loss. But other part is that if a user is saying that I want read scalability, then I can give him additional replication for that. And I mean, it could be either way. Either I can just to the service, I can say I want to support these many requests, and then as a service provider, I will do the calculation or I can ask the service to replicate in these many nodes. I think we can design anyway, but yeah. So I think the better would be that we are saying that we want to serve these many requests per second, and then internally we are taking care of how we are going to provide these many requests per second by replicating or by using some better storage. Like other option could be that if hard disks don't serve 5 requests per second, we are using some SSD or something which can serve more requests. So it's up to us. But the user is saying that I want to serve these many requests, then we are taking care of it and handling it.
Okay, so first of all, these read and writes for this object storage are always really slow. They are not like really fast. And then there could be some if we are getting some more reads or writes for some activity or something, then there should be some layer of caching. How I can make it fast, or it's like CDN or whatever. There are other terms, but I feel that telling user, okay, you replicate this much time, then the user should also know what is the advantage and disadvantage if I make it 1, or if I make it 10, or if I make it 100. So what I'm getting from your point is like, if we are telling user, if you make a higher number of replications, will support a better latency.
Better
latency read better reads latency.
It is something across the region, because I was looking into the S3 pricing, and there's a section of the S3 replication pricing. So I wonder that, do you guys know how S3 handling the replication?
So I think S3 we have to specifically tell, okay, make it multi-region or multi-availability zone. Then if I'm getting a request for different region, we'll reroute that request to that region. But let's say everything is on US West 2, then all the requests will come to US West 2. And then if it is slow, then it would be slow.
Okay.
Like I'm just getting what is my understanding. And
so
I'm just seeing as a customer, like if I have to use your service, what advantage I will get because if I'm putting 10 replication, I'm paying more. But what is the benefit I'm getting out of it? Like it could be more durable. Okay, durable should be there if I do 1 replication or 10 replications. And then we are talking about the read latency.
Yeah, if the read latency, it makes more sense if this is about across the region.
But anyways, I think we can proceed further. Anyways, we have to do replicate. Either user is telling or not, we can go ahead. I don't want to disrupt your flow.
Yeah, I think a good thing would be what Asim, you and Hiran, you have mentioned is, wait, how do I remove this? So user is probably specifying that what is my reasons, that in what reasons I want the data to be replicated to, right? So that now we have to take care of replication in those regions.
Yeah, and that is also not when we are writing. Actually, when we're creating a bucket or a folder, whatever different, that time we tell, okay, this bucket would be like multi-region or whatever. Then whatever data we write, it will get replicated.
So what you said, it's not during the write, or it's during what? What did you say?
So during write, we don't tell it should be multi-region. It is the property of the bucket.
So by bucket you mean subscription?
The parent folder or parent container.
What kind of thing will the bucket say? That is this bucket for cross region, or this only for one specific region? like will the bucket of its parent say that this bucket, the data for this bucket stores only in the maybe US West, or
Mhm.
this thing that this is duplicated in different regions?
I think so. That is the case.
Okay, so you say that the bucket will say that this this data exists in certain regions, and when the API calls for this call data, and the API call will seem to me that it will either say that if we have this data locally, so we can access local data, or it doesn't have the local data, I need to go to a different region to get the data. Is this correct?
Uh,
I think uh, I think it would be something like when if your data is geo-replicated, so at the request, you are routing. So for read, I'm talking about read, and so you will be routing your read request to those data centers
Okay.
or close to the request, right? So if the request is coming from Asia and you have a data center in
in
Asia,
Asia. Mhm.
you will route your request there.
I see.
And during the writes also it will be same. So during the writes also, if the writes are coming from the Asia's request, so first they will be returned to the Asian data center, and then
Mhm.
synchronously they will be copied to other data centers, because we have to replicate to all the data center, but to provide lower latencies, first we will write it to our local data center, we will make copies there, and then we will replicate across other data centers, right?
Mhm.
Okay, I see. Yeah. Then, yeah, I think then they're having the replication factor and some metadata may not make much sense here.
Yeah. I don't know about how this routing tables and all are actually about routing the request to these data regions and all. Does someone know more? Like, I just know that there are these routing tables which will route, but is there anything more in them? Is there anything else more fancy in them which you should know?
Routing, what kind of routing?
Like how are these routing tables created, that where should the requests be routed?
I'm thinking that the data could be routed. We should have some consistent hashing table, like we
So,
can teach.
but I think for now, let's think like this is one region and just finish our design.
Okay.
Yeah, so with one region, so yeah, so we had this design. One thing which we have missed is, which Asim has mentioned, is how can we use caching and all to make our reads faster for same data, right?
Mhm. But first, we need to decide how many replicas are good. Like we can decide, okay, three is a good number. Just replicate and be done with that. And then if there is high load for the same file, then we can just cache it, or internally we can increase the replicates, something like that.
Yeah, right.
Is there any good reason why they say like 3 replicas or anything? Like, I don't know why. I have heard people saying that if you have 3 nodes, you can get quorum easier. But again, your replicas is again 3. Like, is there a reason why it is 3?
So what I know is that first of all, you want 2 replicas. That's for sure. And then the two replicas can live in same stack. And then one should live outside a different stack. So if that entire stack goes down, you can still have one more living outside that range.
Okay. Okay.
The reason for having one in the stack and one outside is uh, so see that if you are separating it in a different stack, the advantage is if your data center dies, if your entire rack dies, you have that other rack which has the data. But the disadvantage of separating in a different rack is your latency will increase, because now your requests will be going over internet. So when you're doing any replication, you are making requests cross data centers, which will take more latency. Whereas if your data is replicated internally within the rack, internally it's that local internet, so it will be very fast. So
yeah, correct.
Considering both the factors, you need to replicate one within the data center and one outside the data center.
So one within the data center is because you want to do it as quickly as possible. Is it?
Yeah.
Okay.
Because within the data center, you have your local internet, right? Your machines could be connected locally. And whereas cross data centers, you have to use public internet, which is slower. So, and you are like, the distance also increases. So all those factors.
So is there any disadvantage if you just replicate, like you can have data in one data center and replication in another data center, like just having two? Is there any problem with that?
Yeah. So the problem is that, so one thing is, so your replications are either synchronous or asynchronous, right?
Yes.
So if
Okay.
your replication is synchronous, means your request will be successful once you have copied it to all the replicas. In this case, we have two replicas. Then
High
you are
latency.
making your request slower, right? Because you are waiting for two.
High
If it is
latency. Okay.
if it is asynchronous, then the point is that if the problem with asynchronous replication is you're losing the durability, because let's say on this my one machine, I got a request and it was successful and I returned success to the client. And now before I could asynchronously copy it to the other data center,
My
my
machine died.
machine died. So now to the customer, you have returned that your data was successfully returned, but actually your data is lost. So you have lost the durability. So that's why for that synchronous part where you want to do synchronous, you do within the data center and then you asynchronously copy across the other data center. But I was just thinking that if your whole data center dies, then you have lost.
Okay. Okay. Oh, that makes sense. Okay.
Yeah, I do have a question about the replication distribution. Let me share my screen a little bit. Can you stop sharing?
Yeah. My mouse is not moving. Can you override?
Oh, this stops. So if you see from here, I will draw something different here. Not showing anything. A second. So I have a question about the actually about the replication distribution. Like we have everything in, we have a group of data like this, and we treat them like a group, and in each group we have a different replication, like node 1 is distributed everywhere, and the node 2 everywhere, and so we can have another group here, and Like we have the 3 here. This is another group. This is one thing. This is everything is evenly, and there could be another another design. I think another design that we can make this more distributed. Like we have different groups. Like we have one distributed here and distributed here, and also we have 2 distributed here, and we have 3 maybe here, 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 and 4 maybe here, here, here. So I want to know that what's a good and bad thing about these 2 design. Like the first one is obviously easier to design because it's in group, and but I see a lot of design outside. They are trying to distribute the replication in different nodes evenly. Like if we have the 3 node 3, sorry, the chunk 3 is in this node, and they will try to let the replication of the 1 into different node other than those 3. So I wonder that what do you guys think about these 2 ways of distributing? What is the advantage and disadvantage of these 2? Because I can't think about any reason about this.
So just I was thinking one advantage could be the good thing about randomness. So let's say if you scroll up, can you scroll up your other design? So here, so everywhere the replication is 1 2 1 2 1 2, right?
Yeah.
And if my requests are in such a way that I am getting too much load for 1 and 2, right? Both 1 and 2 data at the same time, then because all the machines have replication in this way, all of the machines will be overloaded because 1 and 2 is together. Whereas with the other design, so 1 and 2 are separated, right? So that's why like I won't get all the load on one machine. So
the load is more evenly.
Yeah, because of the randomness, like we have evenly distributed the data, so there are less chances. And this is what I just thought. I'm not sure if this is actually the reason or not. But,
Yeah, because I have a question that because I remember that in Kafka it's designed in such a way that they're trying to distribute the replication evenly into different nodes, and also in Cassandra, I think this is also designed something similar. There is something called a virtual node, but trying to really distribute the data replications into different nodes. So under there, yeah, maybe that makes sense because if we're using the first pattern, that each node have the similar amount of data replicated, and they may suffer from the same problem. Maybe there is some bug in the program that cause the same group of nodes all have the similar high load, and then it will fail together, more likely.
yeah.
I see. Yeah, that's my question. So yeah, I think that we can continue to the next question. Is that how we can recover from the disk failure? Abhishek, do you want to continue?
Yeah, let me share the screen. My mouse is somehow not working.
Okay, I think you have to laptop?
Okay, I think it's fine. It will work for this meeting probably. Okay, if the replicas fail, right? If one of the replicas fail, um,
Actually, one disk, so that could be part of the node.
okay, right. One disk fails, and that disk might be having multiple nodes, right? It could be.
That node, that disk should have multiple chunks of data.
Yeah. So, how would it be a problem? Because we are doing the replication, right? So
Yeah.
replication will handle it, and that replication system will like take care that if the node fails, if it has not recovered. So basically, they use these heartbeats mechanism, right? And if a node has not responded for a particular time, then they will consider that node dead, and then they will create a new node because we want 3 replicas. So this is one interesting problem. How will we set up a new node? Let's say we have 3 nodes. Now one of the node died, right? And one of the node died, and now I want 3 nodes in my system. So now I have to fill up this new node. So I have this node with some data. I have another replica with some data. I want to set up a new node, and I want to make it as a replica. So how do we do that?
This time we will need to sync the data.
So it's not an easy problem because the problem is that the data is in flux, right? Data is always moving. So you cannot take a copy of data as it is, because if you will just start copying the data, by the time you copy the data would have changed. So, right?
There's also always a way to have a snapshot of the data.
Right.
That we check, we find the snapshot and we copy all the data during this time. And when it's done, we can, I don't know, maybe we can keep on going and take another snapshot until the data is in sync, or maybe
Yeah.
other approach.
Right. It's something similar. So you take a latest snapshot that you know of the data, you apply that snapshot, and then whatever data came after that snapshot, that will not be a huge amount of data. So there you can apply those logs. So what database do is that they will say that from this point in time, let's say I took the snapshot at time t, then whatever were the replication logs after time t plus now, give those to me and I will play them on this machine, and that's how it will apply the data. So
okay.
I have a question. So, for example, one of the hard disk you failed, like you said, and then you replace the hard disk, right? And now because there is monitoring service running, it will see that, okay, there is this space available, and it will copy the new data in that place. So how can we avoid that situation? Or is that not a possible case?
so you are saying that now after a failure, when I brought up a new machine, that new machine should not be considered for like taking new data. It should be considered for replication. Is that what you're saying?
Yeah, that should happen, right? Because if you're just talking about a hard disk failure, right, your other hard disks are still working,
Can you repeat
or
your
you
question?
will consider that node to be down, like whichever is pointing to it.
No, can you repeat the question? I did not get it from again. Can you repeat?
Okay, so the question is, what can happen is, for example, there is this hard disk failure, and I'm thinking like basically a RAID over here, the RAID as an RAID RAID,
Yeah.
and you have like copies of data, right? and one of the hard disk fails. So now what you will do is you will basically replace the hard disk, but your machine will think like there is empty space and there is this monitoring service that you're running on your service. And it will see that there is empty space and it will just fill the data there, the new data basically.
Yeah, and it is, yeah, okay. So
I was thinking something similar than when the hard drive fails. We probably need to find what the kind a list of replication nodes in this disk. Like if this disk have the replication of node 1, sorry, node chunk 1, chunk 3, chunk 5, and we need to tell the nodes or tell everybody that those nodes are having trouble, that there is one replication is down, so let them to replicate by themselves. And at the same time, we will notify the operator to say that this disk is failed, and turn on some light and say that this is failed and please replace it. And maybe the next time the operator replace it with a different hard drive, then this hard drive may be even bigger because the market, because the technology is improving. So then in the time we have a totally new hard drive, and then we can tell the monitor program to say that we have a new space available, and we can start filling. We can start adding new chunks to that hard drive.
yeah, right. So basically, I think we need to separate, like whatever nodes we have to store data, we would need to separate that in two parts. One would be the nodes are used to store new data, and other nodes are used to replicate the data. So this way, if we have this kind of separation, that then we can solve this problem. That if so, first, if we are if a hard disk has failed, then it will pick a new machine from the nodes which are used for the replication, which are available for the replication purpose. So it will pick a new node from that and add it to its replication cluster, and there it will replicate the data. Similarly, if we are adding a new hard disk, we can specify that what like how do we want to balance it. And I think this monitoring service can also take care of balancing it, that there is a balance between the nodes used for the replication and the nodes used to store new data. So whenever you are adding a new hard disk, you just add the new hard disk. I think you are not specifying, and then this logic is taking care of it, that should it consider this new hard disk to replicate, or should it consider new hard disk to store the new piece of data.
Okay. I think there's I think this is the 2 questions for today's session. Yeah, I think it's early. Do you have any other question for the design? Because we still have a lot of time.
I just, if someone wants to talk about how we will do caching and other enhancements, we can talk about that. Asim, do you want to talk about that?
So caching and other thing, what I feel is like it could be like a LRU, like the the basic thing which comes to mind, like you implement something like LRU, if and then if we're getting a lot of requests, then we can serve it. Or people also talk about this CDNs, which I don't know much about them.
Do you think that you really need a caching in the object storage service? Because I think the caching is more like something like in the web service or something in more like a front end. So I think this object storage is usually in a position very, very back in the whole architecture. So I just wonder that if this is really neat or not, because the benefit, really the benefit of the object storage is that the storage itself is cheap and also they're big.
Yeah.
So I don't think the cache may take into consideration in most scenarios.
It depends. Like if calling my hard disk is a costly operation, then I can use cache.
But I feel like generally, so we have limited amount of cache, right? So generally, like in databases and all, you have cache because that database is sitting on the disk, and then if you want to cache some particular key values or something, you can cache in memory. Here, our blobs are that databases itself, right? Those files that we are storing on the disk. So that data, I don't know how we will cache because mostly like blobs are bigger in size and I don't know if they can be cached.
The place I'm thinking cache makes more sense is the accessing the metadata, which stored in probably in each node to
Yeah,
say that how much space, how much, where the offset of the chunks, such data.
yeah. Metadata definitely we can put in cache. I'm not just sure about the blobs itself, that are the cache or not.
Yeah, the blob is usually several megabytes, and it's pretty. I guess I don't want to say that it can fit the memory, but if we really set up a cache, we will need to consume a lot of memory.
Yeah.
Especially the hard drive usually much bigger than the memory itself. Like I heard that in each node there could be several petabytes, 1 or 2 petabytes of data, and the memory may not that big.
Okay. Is there any other improvements, suggestions we can do here?
Anyone have? Okay, I think we can finish this topic earlier. I don't have anything for today. Maybe we can talk about what we are going to do next time.
Yeah, sure.
And we can start a little bit now. So we finished the we have the with last time I think we previously we talked about the file system, and now this time we have object storage, and we talk about the general web service, and what else we want to cover? Anyone have any thinking?
I was thinking about this something like code. What is that? Code. How we maintain
code
source.
deployment system.
Mm-hmm.
Code deployment system.
I think Naga asked this question on the other day.
Yeah, it was very good. Yeah, I would love to discuss that.
So probably we can take it next week.
What kind of question? I'm still very confused.
So it's code. What is called?
Code deployment system.
Code deploy system.
Yeah.
Code deployment. So
Yeah.
basically in the organization there are many teams, and many of them are having their own source codes, and some of the code is like is repeated in both in different orgs. Now, how do you write a system that could deploy this code in all the data centers that are available? Something like that.
Deploying the this is not code build deploy. So deploying the service itself.
Yeah. Deploying the code for the service. Yes.
Okay. Usually, I'm thinking that usually if you have such a system, it will obviously there is some instance there, and typically the manual way is that we can SSH into the host to upload our artifact and the configuration files. This
Yeah.
is one way.
How do you build such a system? That is what he's talking about. Like many teams have different needs. They want to deploy it like this. They want to apply configuration after deployment. They just want to deploy to one data center. They want to deploy to one region. They don't want to deploy to this region, or some features are experimental. How do you manage all that?
Okay.
Yeah, so I think one part is build, like you are building, a developer has checked in the code. Now you are providing that build environment to build. Then you release, we deploy those release. Then in deployments also, like there are
You run
various,
automated tests there itself and
it's
push the
running.
report.
Yeah,
Okay.
and deployments also, like there are various environments that one is dev environment, staging environment, then production environment. In production environment also there are various rings. Like first is like canary ring, then is worldwide ring. Then also all these things like rollbacks and all that. If one of the faulty code check-in is made, it should not affect your production service. Your production service should be up and running, and it should automatically roll back. And then similarly, what happens if your deployment machines are dead, like some of them are dying? How do you balance and create new machines? And again,
I think so. It is also having this, right? It should take the latest code. It should take the latest changes and then merge also. Something like that is also there.
Yeah. Let me try to start this because this is what I know a little bit. So usually there is this is the whole deployment pipeline. So the first stage obviously it's there's a build, and there's a lot of software we can use for this process. We have the TeamCity, we have the Jenkins, and we have like GitHub have something that can configure the build. So when we have the build, we will get some, we will have some artifact, and that will be stored somewhere. There we can be some backend storage to store all these artifacts. And storage. And then next time, the deployment will be, the service will be a different pipeline that we can have. One thing we can do, usually there's one way that we have a compute instance. And there is a agent that waiting there and waiting for the some central controller to say that I want to deploy this thing, maybe an artifact or maybe even Docker, usually the Docker to, this is a control. The control will push the artifact to the agent to let it deploy. Or maybe even similar, we can have the SSH account to let the controller to do whatever he wants.
Okay.
So yeah, this is a deployment. And as you mentioned that there could be a problem that there is a problem how we want to
detailed requirement discussion. Then next week we can start from all the requirements.
Yeah, okay. I just want to give you the overview of how the system works, because there's a lot of things in this pipeline, like how build and deploy and fallback.
Are you talking about like something like GitLab or?
GitLab, I think that's more like in the first stage, the build and store the artifact.
No, it has both. We can write full-fledged pipeline, deployment pipeline.
I thought in the market, like most famous deployment tool is Kubernetes, right?
Which
Kubernetes.
one?
Kubernetes.
I think we are talking about code building deployment system. Kubernetes is a hosting.
Docker management.
See, like everything is hosting, Docker, Kubernetes. This guy would take the parameters and say either I want to deploy on Kubernetes or I can deploy it on something else.
So the benefit of the Kubernetes is that my understanding is that it can dynamically scale the service, or maybe we call it Docker, or maybe a group of Docker.
But that is not the responsibility of code building deployment system.
Yeah, this is more like in the second part.
No, I don't think so. It's not even in the second part. It's so what is the responsibility of code building deployment system? It will try to push the code on Kubernetes. If it is successful, good. If it couldn't, it will roll back.
Oh, okay. The rollback is basically a version. Like if we deploy V2 and we feel like V2 doesn't make sense, it will fail our service, we can deploy V1.
So code building deployment system has a couple of things like you checked in your code. So storing the code and repositories, I think could be a different use case to solve.
That is like GitHub, right?
GitHub. It's like a Git. Everybody has like open source and everybody has created their own version on top of it. Now they have extended that to deploy the code also. For example, GitLab, which internally use all Git commands. But now you can even have a build, deployment and other pipelines there. So basically, as you do a check-in, it will run a build. If it is succeed, then it will run unit tests. Then it will run quality checks, and then it will deploy it on
any platform that you suggest in the config file.
Yeah, we will define the configuration, how my unit tests, how the things will look like.
Yes.
But it could support different languages, Java, .NET, Python,
Go and anything. Yeah.
So basically, this guy will know, will have some what they call runners, and so it should have some runners where it will do the build. So if it is a Java, it will try to get a Java runner. But if none of the runner is available, it will wait.
Yeah, I think the source repo will be something different, and everybody likes.
So source repo is a different thing. Doing a pipeline of building deployment is a different thing.
So the current build, I think you're talking about the build runner. That if you have the one project or pipeline, whatever you can call that, that will download your source code and run different steps. So for example,
Yeah, so somebody mentioned we'll have a configuration like, okay, to build the code, these would be the command. To run unit test, this is a command. Then there could be like a quality check. If your unit test coverage is less than 90%, throw error. That would be in the call. I think next step, quality check.
Yeah, usually I never see anybody have this trick because the coverage usually very low. But yeah.
Okay, let's make it 50%.
I will see the most projects have the 10% of coverage.
No, I think these days, okay, that was happening before we had these kind of systems. Now, let's say you put a org level policy or like a project level policy, because who is creating this pipeline could not be developer. That could be a DevOps person. He or she can put like, okay, code coverage is 80%. Now, unless you make 80%, it won't let your pipeline to pass, and you can't change the policy. So forcefully, you have to write now. That is the new mandate. Like, make a check in the deployment system that won't let you bypass this step.
Yeah, that's right. You can have the unit test do something.
Then there is quality checks. These days, people also put in
the accessibility test as well.
Quality checks are, I think, something like this, that these many reviewers should approve.
Yeah, your CR was approved or not. 2 people have approved. But I think that is the first step itself to start the build. Because it won't let you merge your code if you don't have...
So then the same thing applies for this unit test and test coverage, right? That it won't allow you to...
How that will happen? Until you don't merge your code, how the build system will know there is 80% coverage or not?
Yeah, right.
So it has to run the tests and generate the report.
That's right.
And then when I say quality, that was like these days people put that coding style check, that the method, the lines in the method could not be more than 10 or 20.
Linting.
Yeah.
What is that?
Linting. LINTING. Linting.
It's a different, it's a different thing in different.
I thought that's all usually covered in the code review process.
Code review process, yes.
Yeah, because
it could not cover, right?
Because usually if you build a code, there will be legacy code. Some people who left the team have some quick and dirty thing, source code, so we cannot unify most of the source code.
No, I agree. But right now, these days, everything is like a microservice. So we are building new and it's small, and this is mostly when you're doing something new. You can even say like, oh, I don't want this step of linked. Then that's absolutely fine because your legacy code does not support that.
Yeah, you can provide annotations and then the linter will skip that part.
Yeah, you can even provide annotations in your code. It's just a property of your code check. What it will skip and what it will pass. But again, it's like a Java project. It would have its own way of doing. But we are just right now putting different things. What could be possible?
Yeah, there's a thing also. There's something like the code scan something usually.
Yeah, I think it's all same, like linked code scan. Whatever you are merging, it will try to check whether it is complying the project policy or not.
Some static plan that will check if there could be any potential security issues in your code. I know that some team is doing this in my company, and this integrate in the pipeline. So yeah, anyway, there are usually, if we are building such a system, we will support different steps, like the build the code and unit test to generate a report, and do the other things like statistic scan, linting, and finally there could be a step to publish artifact, or maybe publish the Docker to somewhere. So this is the feature of the build system. But building this system, do you want to talk about how we are building, creating such a system? Like, because the build and deploy are quite different. So I think we can focus more on the build first. What do you guys think?
Yeah, publisher. Yeah.
Okay. So we have a few minutes, but we can have the start, and we can talk about such a CSV system next time. So let me get something very simple first.
Sure.
So do you think the requirement of the build, like how many projects daily? Like we can assume that we can have maybe we can have 10,000 project, and do we want them? Maybe that's 10,000 maybe reasonable, and every day we want them to, most of them, maybe 50% of them to be built, daily built at least once. And each build will have different steps, like we can build, we can publish, and we can have the generating some reports like unit tests if everything works, and the code coverage, and also the static check. Not the static check, I think that's the term. So there's each project will have different steps. And
I think we just need to give the configuration, provide like a way to configure, and then every project can run its own way.
So, and custom config. And yeah, I think this it's pretty straightforward. And each project may need to run 30 minutes. That's my assumption. Maybe that's the number. And I want to because I want to say something that is out of scope, like the storing the artifact. Because we assume that there is such a place that we can publish our artifact and can be pulled by the deployment system. So yeah, I think this is a requirement. So let's do some basic calculation. So we have 10% of the 10,000 projects, and we have 50% of one day. So we have 55,000 projects built every day, and each of them need 3 minutes, which means that we need to build the project this 1,000 hours. 2,000 hours a day. So that's we don't have that many hours a day. So maybe that's it approximately That means that we need to have the agent to build this thing for us. So every day, let's say we have 8 hours because we want to do it in the daily work. So that means that we have 300 agents doing our work every day. So this is basically, the system should be a system that at least need to have 300 agents to build a job. And we may have one or multiple controllers to do our job.
And yeah, like agents could be like Java, other different languages also.
Yeah, and the agent, yeah, that agent should accept most of the build languages like Java, and maybe have the JavaScript, TypeScript, anything for the web. And we also need to run any native code. And yeah, and it doesn't really matter. So we just know that those agents can build job.
So
And
generally, I've seen like sometimes we have agent which is like containers. So you can just create an image like Java image and build your code and be done with that. But that is again in design.
yeah, this is something I believe team specific, because most of the team may only need to build Java and only need to build whatever JavaScript, TypeScript, or any JavaScript thing because most of the team are building the web service. Maybe some teams building some native code, like they have the C, they have the Go, they have other languages doing some specific work. They can provide the Docker as part of the build config file. So yeah, that's not really a big problem. The only overhead is that when we start a new build, we need to pull those Docker from somewhere. And under such system, I would say that we can make the system to be eventually consistent, not eventually consistent, something like I think this is the right word, right? This is that the system can build multiple times, and we can choose any of the build. So yeah.
So why do we need idempotent here? Like, if it fails, if the build fails in the middle, like if the machine was dead, we can just start the build, right?
Yeah. I mean that if the reason why I put this here is that we may have the scenario that the build the build agent successfully build everything, including publishing the artifact, but it will fail. The agent failed in the last minute. If you never tell the controller that the build is successful, so the controller may decide to schedule another build and start a new one, and it may fail because we may have same artifact with the same version published to the same place. So I would say that this is acceptable if we find the same artifact is published, or the same artifact with the same version is already released. Because yeah, we have 300 agents, and the system may not be very stable because of different issues. Like we can have the multiple controller, and some controller may need to be patched for security reasons. So yeah, that's the basic structure will be like that. Someone messaged something.
Oh yeah, I need to drop. Probably I'll catch up you guys next week. Then.
Okay. Okay. Yeah. Maybe we can continue to talk about this topic next time.
Yeah.
And because I am doing this, I can have some idea.
So I think there is one video what I was looking. I can share. So this also talks about designing a build system.
Oh. Okay.
Like it's
Yeah.
like an actual interview thing.
Actual interview.
Like one person is asking, the other person is solving.
Okay. I see. Yeah. We already have the.
Go in. I've done a lot of Google coding interviews on this channel in the past. By the way, if you're preparing for your.
Okay. Yeah, we can stop here and we can see everybody next time. Continue about this topic, building a build system first.
Okay.
Okay. Thank you, guys.
Thank you.
Thank you.
Bye.
Bye.
Bye.